Good day, everyone. Welcome back. Today, I'm going to be teaching you about calculus. It's an introductory class. So I'm going to be telling you more about calculus, and I'm going to be showing you what calculus is about. And make sure you use your note and pen, so you're going to jot some important things down. With this understanding, you will no more be afraid of calculus. Calculus will be a piece of cake for you. So my name is Calabo Divine, and it's so nice to have you into this class. Let's go. So calculus, the first question I want to ask you is, why engineers and scientists can't escape calculus? Do you know the reason why? Let me tell you why. Calculus is one of those subjects every university student hears about, and almost everybody is afraid of it. But here is the truth. Calculus is not just harder maths. Calculus is the language of the physical world. If you're studying engineering, physics, computer science, or you're studying any science-related course, calculus is the tool that helps you describe change, predict behavior, and optimize systems. In this video, I'll explain three things. 1, what calculus really does. 2, why it matters so much in engineering and science. 3, the core ideas you must understand to succeed in your exam. Remember, this video is exam focused, so the knowledge you get here, you apply it while preparing for your calculus exams. So let's go. The big idea of calculus. At its heart, calculus answers two powerful questions. Question 1, how fast is something changing? That is what we call differentiation. For example, how fast is a car accelerating? How quick is the temperature changing in an engine? How rapid is voltage rising in a circuit? Differentiation has to do with how fast something is occurring. It will help you to find how fast that car is moving, how fast the temperature is rising in that engine, how fast voltage in a circuit is rising. That's how differentiation works. Now, the second question is question 2. How much has accumulated? This is what we call integration. How much? For example, how much distance has a car covered? How much heat energy has built up? How much water is now inside a tank? Integration helps you answer these questions. How much? Accumulation of things. So in simple terms, I can say differentiation measures change, while integration measures accumulation. You can write those things down. So now let's just look at integration. Accumulation made simple. So I will just focus briefly on integration. Now let's think about this question. What is the total amount that has built up? For example, in engineering now, imagine water flowing into a tank. You already know the rate of flow, that is in liters per hour. You want to know the volume after 5 hours, the volume of water inside that tank after 5 hours. This is exactly what integration does. The rate tells you how fast water is entering, while the integral tells you how much water is inside. This same idea appears everywhere, whether in fuel consumption, electrical charge, stress accumulation, energy transfer. Once you understand this idea, integration stops being scary. So now, let's look at why calculus is vital for engineering and science. Let's see how calculus shows up in real fields. For mechanical engineering, analyzing vibrations in bridges, you can use calculus to analyze vibrations in bridges, to study heat transfer in engines, to predict how structures respond to loads. All these rates of change and accumulated effects is why we study what? Calculus. For an electrical engineer, you know that voltage and current don't stay constant, and they change with respect to time. So calculus will help you to what? Analyze circuits, design filters, understand signal behavior. That's what it does for an electrical engineer. These are real-world examples. For those studying physics, calculus will help you explain planetary motion and orbits, motion under gravity, electromagnetic fields. Without calculus, modern physics is literally collapsing, or it will literally collapse. So you need the knowledge of calculus to know how to calculate all these things. For those studying computer science or data science, even in software, calculus is needed. It's needed for optimization problems. It's needed for machine learning. It's needed for gradient descent algorithms. All these rely on derivatives to minimize error and improve performance. But there's one thing you need to know, which is the bridge to calculus. These are called limits. Before derivatives and integrals, there's one critical concept called what? Limits. So now, let me tell you what a limit does. A limit answers this question. What happens as a value gets infinitely close to a point? Can you answer that question for me? Why is this important? Why is this important? This is important because average speed is easy to calculate. Average speed is easy to calculate. Instantaneous speed is not easy. Limit allows us to zoom in infinitely. It helps us to turn averages into exact values, define derivatives properly. This is how we move from speed over 10 seconds to speed at an exact moment. So that's what limits help us to do, to know the exact speed at that moment. So from the average, you get the exact using limits. Now, let's move to the next one, the core idea that power calculus. Now, I'll tell you a secret behind all calculus. These three secrets are very important. Okay, let me just say this is the secret number one. Break a complex problem into infinitely tiny pieces. After that, you solve the tiny pieces. Then finally, you put everything back together. So this is the secret of calculus, or the idea behind calculus. Derivatives focus on one tiny piece, while integrals add all the tiny pieces together. Once this clicks, calculus becomes logical and not magical. Now, in conclusion, I'll be giving you some exam success tips that you can use in your university as a student. Tip number one, don't memorize blindly. Understand the word geometry. The geometry simply means 1, derivative, which is the slope of the graph, and 2, integral, which is the area under the curve. You must understand this geometry very well if you want to succeed in your exams. Tip number 2, master algebra. I cannot emphasize on this enough. Most calculus mistakes are not calculus problems. They are one of these three things. 1, poor simplification. 2, sign errors. And 3, weak algebra foundations. If you're experiencing any of these, you need to go back to your algebra before you enter calculus. Else, you have issues during your exam. And the third tip I have for you today, if you want to succeed in calculus, is what? Tip number 3. Focus on the fundamental theorem of calculus. This theorem proves that differentiation and integration are what? Opposites. If you understand this theory, you understand the heart of calculus. If this explanation helps you, then calculus is no longer your enemy. It is your tool. And if you enjoyed this video, please make sure you hit the subscribe button, you like, you share to your friends, and you turn on the notification so you know when we are dropping the next video. See you on the next one. Thank you.